Chapter 7 is about a whole new topic called hypothesis tests. We'll use a lot of the skills we've learned recently in chapters 5 and 6. What a hypothesis test is the process of using information from a sample to evaluate a claim or test a hypothesis about a population parameter. So let's just say, for instance, that maybe there was an advertisement for a new car that said they had a great fuel efficiency. They said that the mean average fuel efficiency for all of these cars was 50 miles per gallon. And maybe we wanted to check and see if that was legitimate, if that could be substantiated by some data. So we went out and asked them if each of us could have one of these new cars to drive around for a while and see what kind of fuel efficiency we could get. So maybe we had a random sample of, let's say, 30 of these vehicles, one for each person in our class. And from that random sample, we had collected information and calculated a mean for our 30 vehicles, and that mean came out to be 37 miles per gallon. So the idea is, if they're claiming 50 and our information came up with 37, do we think we have the information we need to prove or verify they're 50? In other words, do you think 37 is close enough to 50 to present enough evidence, or does it seem like it's too far away? That's kind of what the whole process is about. We want to compare our sample with the claim and decide if we think we can confirm or if we are disputing what's said in the advertisement. Here's an example of what a whole test might sound like. Once we get into section 7.2, we'll know all the ins and outs. Something like USA Today report states the average age of commercial jets is 14 years. A certain airline claims the average age of their jets is less than that. So we have a sample of 36 jets and find their average to be 11.8 years. Kind of like we were saying up above, do we think 11.8 is close enough to 14? And this section will help us see all the steps necessary to decide that. So one of the things we'll need to do to get started is set up our hypotheses. And a hypothesis test always has two hypotheses. One is called the null hypothesis, and the symbols for it is H with a little 0 as the subscript. The other hypothesis is called the alternative hypothesis, and its symbol is H with a little A for alternative, 0 for null. So the idea is that between these two hypotheses, we'll represent every possible situation in the particular example. So the way we know which one is which is the null hypothesis has to have the equality symbol. So that means if the problem involves an equal, a less than or equal to, or greater than or equal to, we know that symbol has to go next to the null hypothesis. And the alternative, because it's going to be opposite, will not have an equal bar, does not contain a statement of equality. So the possible symbols for that are not equal, greater than, less than. The reason we want them to be opposites or complements is so that we know one or the other has to be true. If one is true, the other has to be false, or vice versa. And the thing that makes these a little bit tricky down the road is either one of them can represent the claim. It just depends if the claim has that equality statement in it or not. So sometimes the claim will end up next to the null hypothesis, and other times the claim will end up next to the alternative hypothesis. And we'll see a lot more about that in just a minute. So because of the regulations, the rules that we need to follow as we set up our hypotheses tests, we have a couple of possible combinations. Like, let's say the null included an equal sign. Then the alternative, because it's opposite, would have to be not equal. Or maybe instead of an equal sign, the null contained a less than or equal to, and because alternative had to be the opposite, it was a greater than. Or maybe the alternative included a less than symbol, and because we know the null has to be opposite, it would be greater than or equal to. So we end up with 3 possible combinations. So we're going to practice filling in those hypotheses, starting off with claims that are already written in symbols. So the idea is we have a claim here. We'd like to decide whether it would go next to the null or alternative hypothesis, and then fill in the other one to complete setting up the hypotheses. So first claim, mu is less than 128. Less than does not include an equal sign. So we said if there is not a statement of equality, that needs to go next to the alternative hypothesis. And we also said that the null needs to be the opposite. So we'll still see this symbol mu, and we'll still see the number 128. It's just that inequality symbol we want to flip around. So we know the opposite of less than is greater than or equal to. The second claim, p equals 0.21. You might pause the video, see if you can decide where it goes, and then see if you could also complete the other hypothesis. Since this one does include an equal sign, a statement of equality, we know it has to go next to the null hypothesis. And then the alternative should be the opposite, so we want the same letter, same number, opposite symbol. The opposite of equal would be not equal. The next 2 examples are very similar. It's just that this statement, the words now give us the claim. So we need to figure out what symbols to use and then decide where it goes and what the other hypothesis would be. So let's see, a shipping company states that its number of errors per million shipments has a standard deviation sigma less than 3. So it looks like here's the claim as far as translating it into symbols goes. We want to use sigma to represent the standard error, a less than symbol to represent less than, and 3 is our number. Since less than does not include an equal sign, does not include a statement of equality, we're going to put that sigma as less than 3 next to the alternative hypothesis. And because that's the claim which we want to identify, let's put a little star there. I usually use an asterisk to represent the claim, or if you want to just write the word claim, that would also work. Now for the null, we want to show the opposite. So the opposite of less than 3 would be greater than or equal to 3. Push pause again and see if you can complete number 4. So 39% we are likely going to look at as a decimal. Doesn't look like it's a mean or standard deviation kind of problem, but rather a proportion like we saw at the end of chapter 6. So it seems to just be saying that the proportion is 0.39. So I'm thinking about an equal sign. There's nothing about greater or less, just that that is the number. Since that contains a statement of equality, we want to put that next to the null. And it was the claim, so let's identify it as the claim. And then we want to use the same symbol, same number, but opposite sign for the alternative hypothesis. So we've been kind of focusing on how to start a hypothesis test, in other words, how to translate the claim into symbols, decide if it's the null or alternative hypothesis, and get both of them filled in. What we want to think about next is the level of significance and the types of hypothesis test. This kind of helps us move along to some of the next stages of the test. So when we're asked to calculate or to perform a hypothesis test, we're going to be given a number for alpha. Here's a new Greek letter, a lowercase alpha. And that alpha represents the level of significance, which is really just saying how much of a chance of error we're going to allow. You know, you've seen with our confidence intervals, we're never 100% certain about things. We have to recognize that there's a little chance of error. But we do want to keep these alpha numbers, these chances of errors, quite small. So you'll notice we want to keep these low so that there's less chance of making an error. When I say low, I mean things like a 1% chance of error, 5%, or maybe even 10%. So alpha will often be 0.01 or 0.05 or 0.10. And those really do go hand in hand with the 3 confidence levels we saw most often. If we're 90% confident about something, that means we're leaving a 10% chance of error, in other words. So we'll watch out for that alpha number, the level of significance, and incorporate it in the entire process when we learn a little bit more about it. One more thing we need to be familiar with is the types of tests that are going to come up. We have 3 types of hypothesis tests. They're either going to be a left-tailed or a right-tailed or a two-tailed test. And the way you know for sure is to look at the alternative hypothesis. You might notice these less than and greater than symbols look a little bit like arrows. This looks kind of like an arrow that's pointing to the left, and that helps us know that would be a left-tailed test. This looks kind of like an arrow that's pointing to the right, which helps us know if the alternative hypothesis has a greater than symbol in it, that would be a right-tailed test. And if it's not pointing either direction, then that means both tails are involved. That would make it a two-tailed test. Try pushing pause and seeing if you can decide for the 2 examples below whether they would be a left or a right or a two-tailed test. So again, it's based completely on the alternative hypothesis. We just want to look at the symbol at the bottom here and notice that that's a greater than, which means it's going to be a right-tailed test. If we're thinking back to our normal distribution, what we're meaning really is that level of significance, that chance of making an error would be over here in the right tail for a right-tailed test. That kind of helps see why it's called a right-tailed test. That means the chance of error will be over there on the right side. Number 2, the alternative had a not equal to in it, so that makes it a two-tailed test like we saw up here. And that means under our standard normal distribution, the alpha will be half and half. Half at the right end and half at the left end, split into 2 tails. On the next page, we get a chance to kind of practice everything so far, start to bring things together. So again, we want to translate from words into symbols, and then decide whether it's a left, right, or two-tailed test. Also making sure that we identify the claim. So, for instance, number 1, a baseball team claims that the mean length of its games is less than 2.5 hours. I see the word mean. That helps me know that mu will be involved. I see the phrase is less than, so I'm thinking about the less than symbol. Then the number, of course, is 2.5. Less than has to go next to the alternative hypothesis. So here's our claim. That's the statement we got when we translated the words. And we need the opposite of that for the null. The opposite of less than would be greater than or equal to. I say opposite, we're really also thinking about the complement. Everything that's not included here should be included there. And now, based on the alternative being less than, we know that that would make this a left-tailed test. So here would be a great time to pause the video, try completing 2, 3, and 4 to see a bit more. Two looks like we have another decimal involved. And nothing about mean or standard deviation or anything like that, so probably a proportion again. P for proportion. And it seems to be saying that that is the proportion, so that would be translated as an equal sign. And the opposite of that would be not equal. The not equal helps us know that it's a two-tailed test. Number 3 talks about the mean tuition being no more than $25,000. no more than means it cannot be greater than that number. It could possibly be less or smaller. It could possibly be that number, but it cannot be any bigger. So for mean, we think mu. To show it cannot be bigger, let's say it could be smaller or equal to 25,000. That's the statement that we translated. That's our claim. So the opposite then would be greater than. And that makes this a right tail test. Number 4 has a decimal in it, so we're thinking a proportion again. It says that the proportion is at least 0.14. So at least means it could be that number or it could be bigger. P could be that number or it could be bigger. That means greater than or equal to. And we know the opposite would be less than. And that less than next to the alternative makes it a left tail test. So I noticed in our example, sometimes the claim ends up next to the alternative hypothesis, other times it's next to the null. And that's important to note and keep track of because it'll help us in the end make our conclusion. Before we get to the conclusion, we have to make a decision. And we'll find that there's 2 possible decisions in our hypothesis tests. Either we can reject the null hypothesis or not. So the language often sounds like reject the null hypothesis or fail to reject the null hypothesis. And this all goes back to the idea we mentioned back on an earlier page. We're trying to decide if the evidence from the sample is close enough or not close enough to prove or disprove what we're investigating. So based on the last 2 things we've talked about, based on where the claim ends up, could be next to the null hypothesis, could be next to the alternative hypothesis, and which decision we make, whether to reject or not reject the null hypothesis. We have some really particular wording we want to use to state our conclusion. So imagine this kind of like our cheat sheet, so we can line things up in the problem, see where the claim is, whether it was null or alternative, see what decision was made, whether it was reject or not reject. And following this little flowchart, we'll know how to start wording our conclusion. So a good idea to keep this paper handy as we answer some questions. You'll see some homework questions that give us a problem that's already been set up. Ask us to just say what the conclusion could sound like based on the different decisions that could be made. So watch for some questions on homework that ask about the conclusion or interpretation. There's going to be 2 parts. One part is asking what would it sound like if we reject the null, and the other part is asking what would it sound like if we do not reject the null. Keep in mind in the end, we're not going to do both in the same hypothesis test. Right here, we're just practicing what the different language could sound like. So this problem says a researcher claims the standard deviation of the life of a certain lawnmower is at most 2.8 years. So we see that's been translated into symbols and marked as the claim. We have the opposite here. On a homework question like this, we'll have a drop-down box. And that drop-down box will ask you to say either the claim does or does not contain a statement of equality. So let's see in this case, the claim has an equal bar, so it does contain a statement of equality, and that's why it ended up next to HO. So it's represented by the null hypothesis. So thinking back to the previous page, we said if the null is represented by the claim, and we decided to reject the null hypothesis, the wording from our flowchart was there is sufficient evidence. Sufficient, by the way, is just a fancy word for enough. Got too many letters in there. S-U-F-F-I-C-I-E-N-T. There is sufficient or enough evidence to reject the claim that the standard deviation of lawnmowers is at most 2.8 years. So remember again, this language comes from the fact that the null is the claim, and we're saying what it would sound like if we do reject the null hypothesis. So we're right here, the null is the claim. If we do reject the null hypothesis, we want it to sound like this. There is sufficient evidence to reject the claim that. In these initial statements, notice the only word that changes is sufficient versus insufficient, or reject versus support. So there's a couple of blanks on this page here, but the general structures are often the same. So let's see, what if we fail to reject? That goes back to here, because the null is still the claim, but now we fail to reject. So now we're thinking there is insufficient evidence to reject the claim that the standard deviation is at most 2.8 years. There's another problem on the next page. You might choose to pause the video now and see how it's going. Try filling in the language again based on where the claim is and on the possible conclusions or decisions. So this time the claim does not contain a statement of equality, and that's why it ended up next to the null hypothesis. So back on the previous page, 2 pages back, now we're in this section here because HA is the claim. So we're going to use the word sufficient or insufficient in the first blank and the word support in the second blank. So based on our flow chart, if we reject the null hypothesis, we're saying there is sufficient evidence to support the claim. And when we fail to reject, we're saying there is insufficient evidence or not enough evidence to support the claim. One thing that makes this a little tricky for folks is that the decision is a separate step from the conclusion. And again, that's because the claim could be next to either hypothesis. So our decision is always about HO, and then our conclusion is always about the claim. Sometimes they say conclusion, sometimes they say interpretation. 2 steps to finish off a hypothesis test. One last thing to check out in this section is the idea of error. We mentioned that the level of significance is acknowledging that we know there's a little bit of a chance of making an error, making a mistake. So we'll have a few homework questions asking us to say what a type 1 error might sound like in a particular problem versus what a type 2 error would sound like. So here's another example where the claim's already made into symbols. Alternative is filled in as well. So let's see. If we reject something that is true, we're making a type 1 error. So if the claim is true, that means the mean really is 16 gallons per minute, although we've rejected it. So let's look for a multiple choice option down here that says we've rejected the claim. In other words, that one's out and that one's out. Although we shouldn't have, because the mean really is 16. Sounds like option D is our best choice there. Read it over again and see if that doesn't kind of make sense. In option D, we're saying we've rejected the claim, but we shouldn't have, because the mean really is 16. On the other hand, maybe the null hypothesis was false, but we did not reject it. So kind of 2 different ways to make a mistake, accepting something that we shouldn't have. Type 2 error. So now we're saying that the mean really is not 16, but we messed up because we failed to reject it. So failed to reject, let's look for an option that includes that. And we shouldn't have, because it's really not 16. So different from 16. Looks like option A, is going to be the best way to go there. So watch for some questions like that on the homework. Just multiple choice about what a type 1 or type 2 error could sound like.